A simple buffer, is it? Let's see. We have a salicylic acid, diprotic, okay, let's make H2A, HA, A for X. 3.00. I need to convert this to pKa. I guess it will be close to 14, but less. 13 point something. Let's, for simplicity, make it. I have a key, so I can look. I don't have a calculator. Okay, if you calculate for me, I'll be thank you. I just don't have it.
It's 13.70.
Okay, 13.699. 13.697.
I put 70.
Okay, that's what we have. Good. How many milliliters of sodium hydroxide with specific molarity should be added to 100 milliliters of salicylic acid? So we start with the salicylic acid and we add sodium hydroxide. And let's see what pH we are trying to make. pH 3.50. It's here. Okay, let's discuss it. So guys, if I start with an acid, completely protonated salicylic acid. Do I need to worry about one titration step or both titration steps? Just one, because my pH that I desire is very close to pK1, right? So let me just finish this reaction, HA as well as water. Do you see at pH 3.50, HA minus is predominant species, H2A is the second in concentration. And that reaction shows that we have two species, right? That's why you don't have to move anywhere else with the second titration step. Guys, if I asked you about 9 or let's say 11.5, it's not a good one, 12.9 pH. If my pH was up here, would you consider the second titration step? You would. If my pH was somewhere up here, would you care about the second titration step? Yes, because as soon as you move from the midpoint to the right, you start thinking about the second titration step. The first would be completed, and you would do the second. Okay, you had something like that on the homework, I hope. Your homework is different because they're trying to make it different, but hopefully. Okay, so, but we do not have to worry about the second titration step, okay? So, because we know it's a buffer, I would prefer to use moles instead of molarity. Whenever we do titration in class today, we use fractions. That's fine too. But whenever you're just trying to do buffers, moles are good, okay? So what do I have? I have 0.100 molar, and I have 0.1 liter of it, salicylic acid, right? I really don't know how many moles of OH minus to add. Initially, I did not have a conjugate base, but, so this value is 0.0100. What do I know? What is greater, 0.01 or X? This or that? 0.0100 is greater, because I don't want all my acid to be converted to conjugate base. I want to have a mixture of those two, And if X is smaller, then all OH minus will be consumed, and we would still have a weak acid and its conjugate base at the end. Okay, so minus X minus X. So X is less. That's why all of that will be converted to conjugate base. 0.0100 minus X, 0, and X. Good. Here, pH, what pKa do I need to use? pK1. And my base here is HA minus. My acid here is H2A. So 3.00, and pH, sorry, is 3.50. Plus log of X divided by 0.01 minus X. Okay, so for X, 0.5 is that ratio. And a log, you will get rid of logarithm. I need a calculator or my notes. Okay, so 10 in power 0.5 is 3.16. You will just do this equation. I'm just giving you the answer for X. It was 0.00759. I will have one more digits. Okay, that's how many moles of base I added. The question was how many milliliters of the base I added. So I need to convert moles to volume, right? So guys, I'll write on top if you don't mind. So we have 0.00759 moles. And we have 0.100 moles per 1 liter solution. Moles are gone. 1 liter is 1,000 milliliters. I got 75.98. Good. Questions here? Okay, guys, I'm modifying the question. Imagine I wanted pH somewhere here. What would be different?
You change to use A2.
So you would say H2A would be completely converted to HA minus. How many moles of the base do we need for that? 0.0100 moles. So convert all of that to this. We need exactly the same moles of OH minus. And then I would have another titration reaction, second reaction. And I would use the second pKa. And the Henderson-Hasselbalch between this and this to find an extra OH minus I need for the second step. I would add moles to complete the first step, 0.01 moles of base with the second amount of the base, and then I would convert to volume. Are you following me okay?
So you wouldn't have to write out that first reaction, but you wouldn't have to write out that first reaction.
You can just
You
say
would start with the second.
complete it.
Yeah.
And you could say that number of moles of OH minus, was 0.0100 to complete the first step.
And so for the next reaction, your initial moles of HA minus would be 0.01.
Yes. Yes, and you would say X moles of the base. And you would do the same thing, but for the second reaction.
Got it.
And total number of moles would be 0.010 plus whatever else you got for the second step.
Gotcha.
Good. I can ask you guys to go from the base this way, the same way. Okay? Okay. All right. We only have extra pen. What do we have? We have a stripe for the system. H3A, H2A minus, HA2 minus, A3 minus, 3.128, 4.761, 6.396. Okay. Citric acid, pH 5, we are here. By the way, is it a good buffer or not? Okay. If you have to write Henderson-Hasselbalch, what would you do? What pKa would you use? pK2, the closest one to desired pH. And this is your base, this is your acid. Okay, and okay, what's your most concentrated? Is it the question first, second, third, and fourth? Okay. Oh,
HA2 minus.
okay. HA2 minus. What's the next one? H2A, because this difference is smaller than that difference. Okay. What's next?
A3 minus.
So this is 1.396, and that is what? 1.6 something. You're looking at the smaller distance. Let's say from here to here, it's 1.396, and from here to here, it's what? 1.72, right? That's why A3 minus is the third one, because pH is closer to pK3, and the most acidic is the least concentrated. Good? Makes sense? Okay, if I wanted a buffer at that pH, what could we do? If I give you A3 minus, you would titrate it with a strong acid. Do you need to titrate it, use only one titration step or two? This will be completely converted to that, and this will be partially converted to that. 2 steps. First titration step will be completed, and the second would be going on, not completed, but will start. If I give you that species and say add a base, OH minus, right? How can you get this pH 5.00? So this plus OH minus will be converted to this, completely or not? Completely. This will start convert to this, completely or not? Partially. Also, you could take this species, another way to make a buffer, this species and that species in the right ratio, and get pH 5. Or you can titrate, you can add this species, let's say, I can say, like, go and see what you have on your shelf. If you have this and this, you can make that buffer. This and that, you can make that buffer. Anything but conjugate will react. Conjugate will not. So these species, they will not react with each other. Those species will not react with each other, as well as these two. But this species will be happily reacting with that, or with that, because they're not conjugate.
If you had a pH closer to the third pKa, and you were coming from the most acidic form,
Okay?
you would you completely convert it to the HA2 minus and then partially to the A3 minus?
Let's make something. Let's say I want 6.2 pH. So H3A has to be completely converted to H2A, right? H2A has to be completely converted to HA. Because you passed the midpoint, you started the third reaction. HA will react partially. And that's the Henderson-Hasselbalch equation that, you don't see what I'm writing. And that's the Henderson-Hasselbalch you will use with pK3. This is a base, this is an acid. So if you start with 0.1 molar of that, you need 0.1 molar to convert here of base, 0.1 molar to, or not molar, moles, to convert to that, so 0.2 moles already, and some more moles to get the right ratio of the base and conjugate acids. Good?